All right. You're here to hear about the pH. It's always an interesting topic because we come with preconceived notion. We believe we know what pH is, and we have read about it. It's very popular lately. We have heard about alkalize or die. That grabs our attention. We heard about the pH miracle. Who is not looking for miracles? Therefore, we pay attention, we read into it, and we dutifully start measuring our pH, wondering about it, putting little dipsticks in our urine every morning, and feeling that our life depends on it. There are a lot of truths, but there are myths associated with issues of metabolic acidosis. First of all, you need to know that in life we have extremes and we have mild changes. The mild changes is what we are concerned with, not with things that are about to throw you into a shock and death. But we need to be aware that in medical literature and medical lingo, every time we end up in alkalosis or acidosis, this can be a life-threatening condition. If we are in the hospital and the drugs they put us on, or the treatments we are on, or the trauma we had before we came to the hospital, if all these lead to excessive acid buildup in the blood or excessive alkalinity in the blood, that could be a truly life-threatening condition. That is because the pH of our blood is supposed to be always maintained in a very narrow range. And it stays there. It has to stay there. Or else we cannot function, and indeed we will die. Thankfully, we do have buffering systems that are preventing this from happening. But instead of the buffering systems being affected, our organs do get affected slowly if our behavior, if our lifestyle allows the acids to build up in our tissues. And we will learn more today about what acids are, what bases are, what alkalinity, acidity are, and what they are in different parts of the body, so that you will understand that when you eat something that tastes acidic, it does not mean that you are eating acid and that you are acidifying your tissues. This is not the case. You will also learn why you cannot rely on the dipsticks and why they are a waste of time in most cases. You will also learn that sometimes you need to acidify or you will die. And sometimes if your urine is alkaline, you will die. That you want the urine to be acidic. You'll understand all of these things because we will get into slight biochemistry here, and I will try to make it understandable. So please don't be overwhelmed. Be patient. When you learn this, you will feel good. You will know what's happening in your body, and you'll be able to take charge. You'll be in control of your own body, and you will not be continuously swayed by fads, by scares. No scare tactics should make you buy various products that are designed to alkalize you. Sometimes if you alkalize too fast, you will also cause damage, and we will talk about that as well. So all those myths will be exposed, but also the reality should be understood. And then you'll be hopefully more balanced in your understanding of this, and you will not be too uptight about the issue of acidity, alkalinity. Plus, you will put it in perspective. There are many other issues that are just as important as acid-base. And they have to be dealt with at the same fashion that other things have to be dealt with. Let us start first by defining what is an acid and what is a base. Obviously, if you have a lot of base, you increase alkalinity. But when we talk about acids and bases, we talk about two opposites. An acid is a substance that contributes protons to a solution. That's all there is to it. It contributes protons. What are protons? They're hydrogen ions. A hydrogen atom that is positively charged because it's missing an electron. That's all. If a substance like crystals of hydrochloric acid, for example, if you put those crystals in water, they will dissolve, and you will have hydrogen on one side and chloride on the other, H plus, Cl minus. H plus is a proton. Therefore, hydrochloric crystals, when they dissolve in water, they contribute protons to the solution. That makes hydrochloric acid an acid. Now you understand what an acid is. It contributes protons. A base is the opposite. A base is some substance that, when dissolves in solution, takes away the protons. If something becomes highly acidic and you put in the solution a base, it will neutralize the acid because it will take away the excess protons. That is the extent of understanding you have to have about acid and base. When we try to measure pH, we are measuring the level of acidity or the level of alkalinity of the tissue, which means we are measuring the concentration of protons. pH is basically a measurement of proton concentration in a solution. After it has been already given the protons or the base ions and has already adjusted to them, now we can measure its pH and say the pH is 7.35. If it is 7.35, it is slightly alkaline because it's above 7. If it's below 7, we call it acid. 7 is neutral. If you want to be extremely anal about it, it will be 7.07. And in nature, there are no perfect acid and perfect bases. The most alkaline number in theory is 14.014. Sorry, 14.14. That's the most alkaline that is possible, but it never exists in nature. The most acid measurement will be 0. Again, it never exists in nature. It's too acidic to exist. We measure the pH by using a negative log of the concentration of the protons. That is why we go down when the acidity increases. The more hydrogen protons we have, the more acid, the lower the alkaline. So it's the opposite of what you would normally think, because the number we use is a negative log of the actual concentration. And we're also using an exponential measurement, power of 10, and that is why when we go from 7 to 8, our alkalinity increases 10 times. We have 10 times the increase of the decrease in protons in our solution. If the protons decrease 10 times, we become more alkaline. Less protons means more alkaline. That means the number will actually go up in the pH scale. But if we have more acid, more protons, the number goes down. So let's talk about reality here. That was the chemistry for today. Actually, I'm lying. There'll be a little more later. But for now, let's talk about real-life situation. Let's talk about different compartments of the body where we have different acidity. And it's important to know that, because when you say my body is acidic, what part of your body are you talking about? That's already an unreal number. You have to be very specific, because in our body there is a reason for specific alkalinity and acidity in different parts. We must have that because each part of our body has a different function. The stomach has a specific function, which is to digest proteins, to break them down. How do you break proteins down? By producing a large amount of hydrochloric acid. Why do you need a large amount of hydrochloric acid? Because when you have protons in large amounts, they have a missing electron. They're H+. If they're missing electron, they are highly unstable. And they will steal an electron from somewhere else and bind with it. If you have a protein in the stomach, after you ate it, those protons will come into those proteins and start frailing them, like a shoelace after you cut the edge. Start getting frailed. You change the structure of the protein by adding all those protons, and that is how you break down the protein so that they can start being digested. The same happens if somebody, hopefully your friend, pours acid on your face. Usually that's what friends are for. Once you do that, why is your face changing so much and not for the better? Because the protons are excessive in number. They will bind with your own skin proteins. They will be inserted into your own molecules, and everything goes frailed. It breaks down, and that's why things look mangled. That is what happens to the food that you eat if it has protein once it comes in touch with your stomach acid. Why is therefore the stomach needs to be extremely acidic inside the space of it? To break down your food only when you eat, not when you're not eating. Then it can be a problem. You want to secrete the acids in the right time, when the food comes in and when the food requires acid for its digestion. The pH in the stomach is between 1 and 3.5, highly acidic. By comparison, if you drink water with a little bit of lemon in it, maybe the pH, if it tastes a little sour, the pH is 5.5 or 5. Not too bad. You can enjoy that, you can tolerate that. But the pH of your pancreas juices that are coming out of the pancreas to neutralize the stomach acids is more like 8 to 8.3, alkaline. And the pancreas has to secrete a lot of juices that are alkaline because a lot of acids are coming out of the stomach that are very concentrated. So a lot of 8 to 8.3 is enough to neutralize a little bit of 1 until 3.5 that come from the stomach. So you need a big quantity of a mild base to neutralize a small quantity of a very potent acid. Is that clear? That's what's coming from the pancreas. Then we secrete bile from the gallbladder. The bile is also slightly alkaline to keep helping the pancreatic juices neutralize the stomach acids. And then we also secrete fluids from the small intestine, from the walls. And that fluid is also slightly alkaline, about 7.5 to 8 in the pH scale. But the stomach is always going to be highly acidic, and it should be. What should the urine be? The urine should be always acidic. And I'll explain why later. Generally, anywhere between 6 and 7 is considered normal. But sometimes it goes to 5.5 for a good reason. It should not go above 7 unless you do something extreme, like drink what? Drink baking soda, sodium bicarbonate. It's so alkaline, it will alkalize temporarily everything that comes in its way. It will get into your system and quickly come out in the urine and make your urine alkaline. Does it mean that you became healthier? No, it just means that temporarily you alkalize your urine. It has nothing to do with your overall health. You just drank something that was highly alkaline, and some of it got absorbed into the circulation, and your kidneys got rid of the bicarbonate, therefore alkalizing your urine. It has nothing to do with your health in the long run. Anybody could do that, very quickly alkalize your urine. It means nothing because it did not change your tissue level. The most important acid alkaline measurement is the one of our blood, even though it does not reflect the changes that occur in our body, because the blood is almost always going to retain its acid alkaline levels. It has to, or else we will die. Therefore, we almost always have our blood level anywhere between 7.3 to 7.45, depending on which part of our circulation is being measured. If we measured alkalinity of our capillary system, meaning the place in between, the capillaries are not the arteries, are not the veins, they are in the middle. If we measure the capillaries, they will be right in the middle, 7.35 to 7.4. If we measure the veins, where we have a lot more carbon dioxide, the veins where we already are trying to eliminate carbon dioxide, we don't have enough oxygen, they are more acidic. So they are 7.3 to 7.35. And if we check the arteries, where we have more oxygen and less carbon dioxide, because the arteries have come from the lungs and they are more oxygen rich, that's where we have 7.4 to 7.45. So the total is 7.3 to 7.45. That's the blood. What affects our health then? Why is all the talk about pH? What affects us is what's happening in the cells. Our cells have all type of biochemical reactions occurring within them. Those reactions require good enzymatic activity to propagate those reactions, to facilitate them. And those enzymes can only work in very narrow pH range. Even a slight change is enough to render them inactive. Think for a second about getting high temperature. All it takes is 1 degree change to make you feel really sick. Our body is always trying to maintain an even, stable temperature at a very specific narrow range. And the slightest change is all it takes to make us feel ill. The same is true for pH, not just temperature. Our enzymes must work and function within extremely narrow pH, extremely narrow temperature. And therefore, if our enzymatic system slows down, we cannot engage in healthy biochemistry inside our cells, and we die, or we get really sick. What most Americans and Westerners are suffering from today is not real metabolic acidosis. What they have is mild, chronic metabolic acidosis, mild and chronic. It is not acute. Therefore, most doctors are not concerned with that. They don't care about it. It does not kill you instantly. What it does is it gradually erodes your health. And it leads to chronic conditions like kidney stones, loss of calcium in the urine, bone loss, osteoporosis, right, and fractures, fibromyalgia, chronic fatigue are very common. Muscle wasting. Muscles actually break down and become smaller. I'll explain why a little bit later. These are the kind of changes that mild, chronic metabolic acidosis lead to. And we all suffer from that because we have no choice. We have a few choices that we can engage in to improve our lot. But no matter what, we will be a little more acidic today than ever before. And there are good reasons for that. It's not entirely our fault as individuals, more as a society perhaps. But each and every one of us can do something to improve. And we will talk about that today. But before we get into the nice, juicy story of what we can do, we have to talk a little bit about why is it that we have acids in our body in the first place. And why is it that even if you are the healthiest person, living in a utopian Garden of Eden, having nothing but organic, pure foods, all the fresh fruits and vegetables, and some nuts and seeds, and everything is totally natural, no pollution whatsoever, not in the water, not in the air. Everything is just the way it was 5,000 years ago in the Garden of Eden. Even then, your blood will always be slightly alkaline and your urine will always be acidic. And the question is why? Why are you always producing acid and getting rid of them through the kidneys? And the answer is because we eat. We have no choice but to eat. Without food, we don't make energy. In all of our foods, when we eat them, whether they are wholesome or junky, we're going to have macronutrients. Macronutrients are the source for energy in our body. Those are the fats, the carbohydrates, and the proteins. Macronutrients. Every food we eat contains them in nature. Only artificial foods don't contain calories, and they should not be eaten, for reasons we shall mention later in this regard. If you have eaten a food, no matter how pure, you have to oxidize it to create energy for the cellular function within your body. When you oxidize it, inevitably various acids are going to form. Why? Because first, when you oxidize carbohydrates and fats, the end result is carbon dioxide and water. People who have learned basic biochemistry know that already. Every time you oxidize carbohydrates and fats to make energy, you make water and carbon dioxide. When you go to the bathroom and urinate, you think that the water that comes out of your bladder represents how much you were drinking today? Think again. It's not relevant so much to what you were drinking. It's relevant to what you were eating. Because most of the water formed in your tissues is water that came out of your metabolism of macronutrients. That is why you end up urinating a lot when you drink alcohol. Not because it is wet, but because it contains a lot of refined carbohydrates, macronutrients. So you're making a lot of urine because of the water that came out of burning, oxidating the alcohol. What happened with this carbon dioxide? That's the main point. What is going to happen with carbon dioxide? It's a toxic gas. That is why we get rid of it. How do we get rid of carbon dioxide? We breathe, we exhale, right? That's the most common answer, common sense. But it's not the main way through which we can get rid of carbon dioxide because we don't breathe enough. We don't exhale enough molecules. Carbon dioxide is toxic, it's a gas, but only a small amount can bind within our red blood cells and get excreted through the lungs. The vast majority of carbon dioxide cannot do that. So instead, it dissolves in the water of the blood, and when it dissolves with water, with H2O, a new acid is being formed called carbonic acid. H2CO3. You do the math. H2O plus CO2, put them all together, and you get H2CO3. Molecule for atom, they're all in there, on both sides of the equations. Exactly the same number of atoms. H2CO3 is an acid. Why? Because it contributes a proton. And when it does, it becomes H plus on one side and HCO3 on the other side, whereby the HCO3 is the bicarbonate ion. It's negatively charged. Bicarbonate ion and a proton. Therefore, carbonic acid contributed a proton to the solution. It is hence an acid. Now, carbonic acid is a volatile acid, and it's toxic. And it is manufactured in excess every time we eat fats and carbohydrates in a utopian paradise. Remember, it's the cleanest food. It comes with all of the nutrients and minerals, vitamins, antioxidants, fiber, everything that you want to have in your healthy food. And still, it manufactures a potent acid of which we have excess, and the body does not know what to do with it. This is carbonic acid. That's because our lungs were not able to do their job and get rid of all the carbon dioxide. Everybody with me so far? You followed the story? Yeah. Fascinating story, isn't it? We should write a novel about that. Now, I'm so glad you're excited. Biochemistry is so lovely. Now, the carbonic acid has to get out of our system or we will die. And we have a way of getting rid of it. That way is using our kidneys mostly. Sometimes we can use our sweat as well. But our sweating is not enough. We don't sweat too much. Only 1 liter in 24 hours period at the most. And we cannot put too much acid in our sweat. Even a little bit of acidity in our sweat really feels bad. Have you seen the movie Super Size Me? Notice that his sweat started stinking, that he started feeling stinky. People who have acid sweat stink. And that's because they created too much acid in their body as a result of their diet. That acid could come from anything that they eat that has macronutrients, especially if they eat excess of food. It's not likely that our sweat would be sufficient in helping us get rid of all the acid, because our urine can handle a lot more acid substances within it than our sweat, because our kidneys are designed to let go of acids. So in 1.5 liters of urine per day, we can have much, much more acid allowed out of the body than in our sweat. And indeed, that is what happens. Our kidneys have special tubules within them. And those tubules are smart. When the carbonic acid comes into the urine and it is dissociated into a proton and a bicarbonate ion, what the kidney tubules do is very amazing. They somehow know that the protons need to go out and that the bicarbonate must be recycled. And the bicarbonates keep coming back into the blood, into the circulation, in order to keep buffering our blood to keep it from getting too acidic, while the protons are being released through the urine, making the urine acidic. Is that clear? Yes. So even in the most pristine paradise, you are manufacturing acids that will come out through the urine, making your urine always acidic. And that's how it should be if the kidneys are doing their job. You want to get rid of the acids. If you measure it with a little dipstick and it says extremely acidic, and you're going to think, oh my God, well, be thankful that your kidneys are able to lose those acids. If they can't, and your urine is alkaline, maybe you have damaged your kidneys so much that they are not able to secrete the protons through the urine. And maybe even further than that, they lost the ability to recycle the bicarbonate ion. The bicarbonate comes out with the protons, neutralizing them, and your urine is not acidic anymore. Is that a good thing? No. It's a bad thing. We have so many variables here that you cannot trust that simplistic dipstick anymore. You don't know what it really means if you see the big picture. Don't believe those books that are telling you to buy those sticks. It becomes an obsessive behavior. You all know, and you will know today after this lecture, what you need to do to improve your health. And once you know that, you don't need to obsess about it anymore. No frenetic run for the health food shop to buy that specific thing, or a few others as you shall see. Relax a bit. Okay, your body is a great machine. It will take care of you if you take care of it, and then you don't need to be completely self-absorbed with it. Life is a little better than that. There are more things to enjoy. Get out a little bit. Food is not everything. It's a source of nutrients and a source of energy. It should not also be a source of comfort. We will talk a little bit about that. It should not be a source of addiction. But you almost have no choice. Somebody is pulling the strings, and you are very good puppets. Otherwise, the supermarkets wouldn't exist the way they do and wouldn't be selling what they do sell. You would be buying mostly what is outside here, outside of this front door. Those organic fruits are much better, and other foods too. Now, we talked about utopian paradise, the condition where you have enough oxygen in your tissues, you have enough insulin to bring glucose into the tissues so that you can make energy from glucose in the cleanest way possible. And what is that cleanest way? Manufacturing carbon dioxide. Toxic, volatile gas, and its attendant acid. The carbon dioxide and the carbonic acid, the way they are interacting together in our system is called our buffering system. That's the buffer that prevents any increase in acid or donation of protons from making the blood too acidic, and prevents any excess of bicarbonate from making the blood too alkaline, because they interact and neutralize continuously each other. And that is how it should be. But that was the use of the cleanest environment. Now let's talk about reality. No more paradise we are talking about here. We're talking now about the absolute reality we live in. Do we have oxygen in our tissues all the time? Do we have sufficient oxygen? Look at how we breathe. Shallow, short breaths. Repeated and rapid breathing. That normally happens when we get a little acidic and we need to get rid of more acid. We start breathing more shallow breaths, trying to get rid of more carbon dioxide, but we can never be successful. And if you become too alkaline, as in alkalosis, which can kill you in the hospital because of massive infection or massive drug intake, then you start breathing very slowly to lower the release of carbon dioxide to maintain acidity in your blood. But in your reality, outside of the hospitals, most of us are making a lot more acid, for one, and we'll talk about why in a minute. And most of us don't have enough oxygen in our tissues, partially because we manufactured too many acids and too much of the acids to get rid of it through the kidneys. So we start breathing more shallow breaths, so we have less oxygen. Plus the acid prevents us from having enough oxygen in the tissues. Every time you have acidic tissues, even if you went 0.1 of a pH level down towards acid, you lost 10 times the amount of oxygen that was available to that tissue. And remember, we can only operate within a very narrow range. So that little is dramatic in the level of oxygen loss that we experience as a result. We have no oxygen, also because we have pollution, and many times pollution takes over the oxygen or reduces the partial pressure of oxygen in our environment. Also, our overall level of oxygen in the atmosphere has been reducing, partially because of human interference in our atmosphere. We have less oxygen